Good morning, students. We have the next chapter lined up for you now, and that is light. And as far as physics is concerned, so you see the name of the chapter is refraction at plane surfaces. Refraction is the name of a process. Okay, refraction at plane surfaces. Now, let me brief you first about what we will be dealing with as far as the light chapter overall is concerned. You see, in light topic, we will actually have at least 4 different chapters to cover. Okay, so in those 4 chapters, obviously the very first chapter is refraction at plane surfaces. So if you try to understand basically what light is in the beginning, before we actually go ahead into refraction process, let us first understand briefly what light is. So light, we all know, is a form of energy, quite like sound, although it is different in some aspects with respect to sound. So both actually travel in the form of waves. Okay, so we have light waves, we have sound waves, and so on and so forth. Okay, so in what way is light different? You see, you can say that light is a form of energy that creates a sensation of sight in your eyes. Okay, so with the help of this light you can see the things around you. Okay, so if during the night when the sun goes down, and supposing that you do not have any light source, any luminous source of light available, then actually you are not able to see anything. Okay, so this is a form of energy that incites or enables the perception of visibility. Okay, so this is what we have in terms of the basic understanding of light as the energy waves. Now, you see, please come down over here to these 2 incomplete diagrams. Actually, these are okay. So what I am trying to explain to you over here is that in 9th standard, till 9th standard, in fact, you have pretty much covered the process of reflection of light. Okay, now what is reflection of light? If you remember, if this is a plane surface, or maybe let's say a plane mirror or something, from which you see the other side of which is polished or silvered like this, so what you will do is you will draw the normal to the surface at the point of contact. Okay, so this is the normal that we have drawn with a dotted line. Obviously, I do not need to tell you that this is the incident ray of light that is falling. Okay, that's the surface on which it is falling. So according to the name of the process, which is reflection, this light on falling onto the surface, it actually turns and moves off into the same medium but in a different direction. Okay, so if you call this to be angle I, which is the angle of incidence, you will call this to be angle of reflection. Okay, so and furthermore, you obviously have angle I equal to angle R. So all this process, the name of this process was reflection, is reflection. You have already studied all that. Okay, now the process that we are concerned with right now in this first chapter of light here in 10th is refraction. Okay, so if you read over here, refraction means the bending of light. Okay, so the turning of light, there will be obviously conditions when it will bend and the reason why it bends. Okay, so you see the situation over here. This is the diagram that I am going to take up. Suppose this is medium 1, okay, and this is medium 2. Okay, now what is this particular word medium going to mean? This medium is actually the optical medium. Okay, optical word obviously comes from the word optics. Okay, so related to light. Optical medium, if you read, anything through which light energy can travel. Okay, anything through which the light energy can travel. So if you look around yourself, you will find that let's say, for example, if we are standing in a room right now, we see light source around us in the form of sun, and because of which we can see a number of things around us. Okay, so light is traveling in the medium around us. Now let us have a clear look at the medium around us. around us there are a number of things which we may or may not be able to see. For example, we have a number of gases, gaseous molecules available, we have dust available, we have smoke outside. Okay, so there are a number of things, material things that are present around us. Okay, so that medium is known as the material medium. Okay, so obviously light can travel through it. Now, supposing that we suck out using a suction pump, you suck out the entire material or the entire air or the entire gaseous system from inside a room, suppose. Okay, so now in that room we basically have no material medium present. So in fact it's the absence of material, okay, which is exactly what we call vacuum. Okay, so can light travel in vacuum also? Yes, we will observe that the light, even after withdrawing of the entire material from the medium, even in the vacuum, light will be able to travel. Okay, so when we talk about the optical medium, we say that any medium in which light can travel. It can actually be the absence of medium also in which the light travels, okay, which is exactly what we are calling as vacuum. Okay, so light, this is basically the major difference that you have between light and sound. Sound cannot travel in vacuum, whereas light can travel in vacuum also. Okay, now having understood the optical medium, so now coming back to our diagram, suppose the ray of light was traveling in optical medium 1 and it is now going to enter into another optical medium 2. Okay, so this is the surface of separation that I have drawn. Okay, so this optical medium will have its own material density. Okay, it will have some material present, maybe not visible to the eye, so small. Okay, so this material medium has some material in it. Okay, similarly the second medium, when we talk of the second medium, the reason why this medium is different from this medium is because maybe its optical density is different. Okay, there are maybe more number of particles present here or less number of particles present here. So in that way, this medium and this medium, they are different from each other. Okay, so when such a difference of medium arises and there is a light falling, so the first thing that we do is, once again we draw the normal over here and we say that this is my angle of incidence. Okay, so now the process of refraction, which you obviously have understood, it means bending of light. So the bending of light can be like this, or it can be like this, or it can be like this. Okay, so there are a number of ways in which the direction of the original direction of the incident light changes and we have an altogether a very different direction coming up. Okay, so what are the rules and the laws on which this particular diagram will be drawn and why at all is this bending taking place? Let us understand that now. Okay, so bending takes place whenever there is an obstruction in your path. Okay, now I'll take a very basic real life example to help you understand this process of bending. This was the ray of light that was traveling. Why did it have to turn? Now you will think of a situation in which you are moving on a relatively vacant road. Okay, there is no rush on the road, you have ample space, so you are going in a straight line at a reasonable speed. Now suddenly, suppose after traveling 100 meters, you come to a location which is like a market area and it has quite a number of people traveling on in that particular area. So don't you think you will have to slow down your speed also? You may have to change the direction also. You need not necessarily go in one original direction in which you were going. So you will have to take a different path, or maybe you will have to take a small turn. You will obviously have to slow down or speed up, things like that. Okay, so it is same case that gets applied to this ray of light that is traveling. So it was traveling with a particular speed. Now when it encounters an obstruction in the form of another medium, then at the very surface of separation, its speed reduces or increases. So basically its speed will change. because of which there is a bending that takes place. Okay, so now we have understood why does the bending take place. The bending takes place because there is a change in the speed of light. Okay, so we have the change of speed of light, okay, taking place. Okay, now what is the change of speed of light? So if you recall, there was a formula, V is equal to F lambda. V, now this obviously is for the velocity of wave. Now here the wave is light wave, so we can say that this is the speed or the velocity of light. Okay, then we have F as the frequency of light, and then lambda obviously is the wavelength of light. Okay, wavelength of light. Okay, so in this particular wave velocity formula, when we see, suppose let us talk about a source of light or a ray of light. As long as the source is fixed, we will have the frequency value fixed. So you see, you can say that this F value can be written as V upon lambda. So as long as this F value is fixed, okay, as long as this F value is fixed, you can say that V upon lambda is fixed. Okay, which further means that V is proportional to lambda. When you take lambda to that side, you will have V, velocity of light, directly proportional to the wavelength of light. So when we say, suppose for example, during the bending of light or during the refraction of light, when there is a change of speed of light, obviously that is because of the change in the wavelength of the light. Okay, so when we say there is a change of speed of light during bending, we also mean that there is a change in the wavelength of light. Okay, so if that change is increased, if the speed is increasing, the wavelength will increase. If the speed is decreasing, the wavelength will decrease. Okay, so now if somebody asks you what is refraction of light, you will say that refraction is a process of bending of light because there is a change in the speed or the wavelength of light when it travels from one medium into another medium. Now this medium obviously is the optical medium, a medium through which light can travel. It can be plastic, it can be glass, it can be water, it can be any other liquid. In fact, it can be air also. Okay, so this is the general understanding of the word refraction. Okay, so now coming now to the laws which govern refraction or the rules that we will follow. If you see, these are the two different diagrams that I have drawn. Let us first have a look at this particular diagram. There is a ray of light that is traveling in medium 1. Now this medium is optically denser medium, okay, and the medium into which it is going is optically rarer medium. Now I'll help you understand what is the meaning of optically denser and optically rarer medium. Let us first see the scenario. So this diagram, in this diagram, light is traveling from a denser medium to an optically rarer medium, okay, whereas here it is traveling in the reverse way. So it is like optically rarer to optically denser medium. Now if you observe, let us first understand the meaning of optically denser medium. So optically denser medium can be compared in an analogy. You can compare the optically denser medium to a road which is very busy, okay, whereas an optically rarer medium, you can compare optically rarer medium to a road which is more or less vacant. Okay, so on a vacant road you will travel with a increased speed, whereas when you reach a busy road you will travel with a slower speed. Okay, so now you will always identify your optically denser medium based on the low speed with which the light travels in that medium. Okay, so if you are given two mediums, now I'll simplify things. If you are given two mediums, okay, and the speed of light in one medium is much less in comparison to the speed of light in the other medium, so you will say that the first medium is optically more dense. It is optically more dense, that is why you have to reduce your speed in that particular medium. Okay, so now you have got a fair bit of an idea of what optically denser and rarer mediums are. So the rules are, whenever light travels from an optically denser to an optically rarer medium, it bends away from the normal. Now you see, what does this bending away mean? This was the original direction of the ray. So if I assume that there was no separation of the mediums, the ray of light would actually have traveled like this in the straight line. It would have continued. But did it continue like this? No, it actually bent. Did it bend towards the normal or away from the normal? Here is the normal. So it bent away from the normal. Okay? That's when light travels from denser to rarer medium. Now the reverse happens when you reverse the cases. So when it is traveling from optically rarer medium to optically denser medium, now you see again the original direction of light would have been like this. So did it bend or not? Yes, it bent. It bent towards the normal. See, this is the normal, so normal towards the normal. Okay, so these are the two rules of refraction that you will have to remember. Okay, now just like we had angle of incidence and angle of reflection in reflection, we will have angle of incidence and angle of refraction in refraction. Okay, so this is angle I here and this is angle R here. This angle R is angle of refraction, not reflection. Okay, now coming to another aspect of this particular diagram. So that aspect is delta, which is angle of deviation. Okay, the angle by which the ray bends. Okay, so we will understand this angle of deviation, which is denoted by this symbol delta. The name of this symbol is delta, and we will see what is this delta in this particular diagram. Now suppose that this ray, the original direction of the ray was this. Okay, the original direction of the ray was this. Now this entire thing is angle R, because this is the ray of refraction or the refracted ray, and this is the normal. Okay, this is the normal and this is the refracted ray, this is the incident ray. Okay, now by the very formula of the very concept of vertically opposite angles, if you see this angle I and this angle here, okay, this angle and this angle, they are vertically opposite angles, so they will be same. Okay, so you see this part becomes I. Okay, from here to here this part becomes I, and this entire thing is R. So what will this angle be? Can somebody tell me? This angle will be R minus I. Okay, because you see, once again I am explaining, this is the normal and this was your refracted ray. Okay, so the angle between the normal and the refracted ray, this entire angle is angle R. Okay, whereas because these two angles are vertically opposite angles, so if this is I, this will also become I. Okay, so the remaining angle becomes full angle, which was R minus I. Okay, so this is what is known as angle of deviation. Okay, so you will write this will be angle R minus angle I, but please note that this formula is for this particular case. If you talk about this particular case, the formula will change. Okay, so in essence you must understand what is the meaning of delta. Delta means angle of deviation, and it is the angle through which the ray of light deviates or bends. So this is the angle through which it has bent. Why? Because this was the original direction and it has bent this much. So this angle is what is delta. Okay, so from mathematical geometry we have come across a formula for this also. Now let us talk about the word refractive index. Okay, now we have already started refraction process, so we will study what is the meaning of the word or the term refractive index. Okay, so this refractive index is denoted once again by another symbol which is drawn more or less like a U, but not exactly like a U. You see, this is an extended portion and this is known as mu, M-E-W. Okay, so refractive index is a term which indicates the bending capacity of a medium with respect to another medium. Okay, so whenever we talk about the refractive index value of any medium, it is always in comparison to some other medium. Okay, now suppose this is the way we write it. Now suppose in the book when you read, you will find the refractive index values for different material mediums. You will see that the values are different. Now you see, mu means, obviously this is mu means refractive index. On the right side of it there is a small g written over here. So this means refractive index of glass. Okay, now whenever, just now if you see, I had mentioned that refractive index is always expressed as the bending capacity of a medium with respect to another medium. So when one medium is glass over here, what is the other medium? So when the other medium is not given, you will always treat that to be the air. Okay, so you will read this as refractive index of glass with respect to air. Please listen to this carefully. There is a way of reading this out, and it is refractive index of glass with respect to air. Suppose somebody writes refractive index mu A on this side, G on this side, then this would mean refractive index of air with respect to glass. Suppose somebody writes refractive index of G with respect to W, so this is refractive index of glass with respect to water. Okay, so this is the way it will be read. Now coming back to this particular value, refractive index of glass with respect to air is 1.5 or it is 3/2. Now the obvious question that will come to your mind is, what are the two mediums being compared here? One medium is glass and the other medium is air. Okay, so let us draw a rough diagram over here. This is the ray of light moving, and it is moving from air, which is the first medium on the left side, and it is going into glass, which is the second medium. So whenever you talk about the refractive index of the glass with respect to air, then glass becomes the second medium, air is the first medium. So whenever somebody says refractive index of G with respect to air, you will immediately understand that the ray of light was traveling from air and it is going into glass. Okay, so when this value is 3/2, it shows that the refractive index capacity or the bending capacity of glass with respect to air is 1.5 times. Okay, so now how does this value come? From where did it come? So it came by the scientific observations of the speed of light in glass and in air. So if you remember the very process of bending that we had spoken about, why does bending take place at the surface? By the way, bending or the refraction process is a surface phenomenon. Okay, the maximum bending that happens, it happens at the surface of separation. This is the surface of separation. Separation of what? Separation of this medium and this medium. Okay, so whatever bending has to take place, it will take place right over here at the surface. Okay, now recalling in the beginning of this lecture, I had told you that bending happens because there is a change in the optical densities of the medium. There is obstacle that comes, and therefore the speed of the light changes. Okay, the wavelength of the light changes. That is why bending takes place. Okay, so if refractive index of glass is 3/2 and if refractive index of water is 1.33, how are we getting all these values? From where? So we are comparing the velocities of light in these two different mediums. Okay, so you can now write down the general formula. Refractive index of second medium with respect to first medium is given by velocity of light in medium 1 upon velocity of light in medium 2. Okay, so this is the formula that actually determines the values of refractive indices. Okay, now this is a general formula, that is why I have written medium 1 and medium 2. Obviously, when you take a practical case like this, medium 1 will become air and medium 2 is obviously your glass. Okay, so when suppose we try to convert this general formula into this aspect, you see refractive index of the second medium is glass medium here. What is the first medium? The first medium is air over here. So its value, the value we already know from the book, it is 3/2, but how did it come? So velocity of light in medium 1. So velocity of light in medium 1. What is medium 1? Medium 1 is air. What is medium 2? Medium 2 is glass. Okay, so experimentally it was found that, by the way, velocity of light in air is also represented by a small c. Okay, so you have V glass. Velocity of light in air or vacuum is 3 into 10 to the power 8 meter per second, and velocity of light in glass was found to be 2 into 10 to the power 8 meters per second. This and this gets cancelled, so this is how you get a value of 3/2. Okay, similarly, if you have refractive index of water with respect to air, you will have V air at the top and V water at the bottom, and this way you can calculate the value of this also. Okay, so now we understand that higher the value of refractive index. Now suppose, let us compare. We have one value as 1.33 and one value as 1.5. So this is refractive index of water and this is refractive index of glass. Please note, it will not be one medium, it will always be a comparison of two mediums. So when there is no other medium given, we will treat this to be air. Okay, so now you see refractive index of water with respect to air is 1.33, refractive index of glass with respect to air is 1.5. Obviously this value is greater, so refractive index of glass is more than the refractive index of water. What does this signify? This signifies that when you send a ray of light from air into water and when you send it from air into glass, which one will create more bending? It will be the glass which will produce more bending. Why? Because the refractive index of glass is more in comparison to that of water. Okay, and we have already listed that refractive index is the bending capacity of one medium with respect to another. Okay, so this is the representation or the logical understanding of the refractive index. Okay, so this will be a value. Okay, so the next thing, or perhaps the last thing in this lecture about light, will be Snell's law of refraction. Now this refraction process that we have understood till now, I have once again drawn a diagram over here just to check if you have actually understood the process of refraction. After that we will go to the Snell's law of refraction. Now you see over here, this was a ray of light that was initially traveling in medium 1. Okay, so this 1 means medium 1. Okay, now when it fell upon the surface of separation, this is the surface separating the two mediums. Okay, so the light has bended. Okay, the moment it bends, we can say that there is refraction taking place. Okay, so can you tell me, did the ray of light bend towards the normal or away from the normal? Where is the normal? This is the normal. What was the original direction? This was the original direction. So which way did it go? That way. So that way. So it has bent that way. So that is like away from the normal. So away from the normal. Okay. So if you remember what I had taught just now over here in the same lecture, whenever a ray of light travels from an optically denser medium to rarer, then it bends away from the normal. So if it is bending away from the normal, that is it must have traveled from optically denser medium to an optically rarer medium. Okay, it must have been traveling in a crowded medium and now it has gone into a less crowded medium, if you can call it like that. Okay, so it is very easy to label these things based on the diagram. Now coming back to the law of refraction, just like you had the law of reflection, angle I is equal to angle R. Similarly over here, you obviously angle I and angle R won't be equal because the ray has bended. So you have refractive index of medium 2 with respect to medium 1 is given by the ratio of sine of angle of incidence to the sine of angle of refraction. Okay, this sine obviously is the trigonometric ratio sine, which you have already studied in maths. So according to Snell, refractive index of one medium with respect to another medium can be found out numerically if you know the value of I and R in those two mediums. Okay, so it will be the ratio. Now this is 1, and then obviously if you recall, just now we had also studied the refractive index of medium 2 with respect to medium 1 is also given by velocity of light in medium 1 upon velocity of light in medium 2. Okay, so combining these two, since these two are the formulae for the same refractive index, we can combine them together. So we have combining them, we have refractive index of medium 2 with respect to medium 1 can be written as V1 upon V2 equal to, it can obviously be written as sine I upon sine R. So this is the overall formula that you will have to memorize or remember, and obviously you have understood the formula also. Refractive index of any medium with respect to any given medium can be found out in two scenarios. One, in which the velocity of light in both mediums is given. Suppose you get two mediums and the velocity of light in both mediums have been given. So you use the first formula to get the refractive index value. But if the velocities are not given, then you will be given angle I and angle R, which is the angle of incidence and the angle of refraction. So if you are given I as 30, R as 45, you can put sine 30 and sine 45. Sine 30, you can put the value, you already know the value, sine 30 is half, sine of 45 is 1 by root 2, so you put the values and you will get the refractive index in this case also. Okay, so this is the formula that we will pay more attention to. Obviously there is that other law of refraction which states that the incident ray, the normal and the refracted ray at the point of incidence, they all lie in the same plane. This is quite similar to the first law of reflection that you have. Okay, so you can relate to that here also, but what is more important quantitatively is Snell's law of refraction. Okay, so we will stop here. I think we have done enough for the day. You will please go back and revise light portion, whatever portion we have covered. What is refraction? Why does it happen? Okay, does this bending happen always? What is the scenario in which it bends? Okay, why does it bend in the sense, does the speed of light change? Suppose the light was traveling in medium 1 over here and it is going to travel in medium 2. Does the velocity of light change? Yes, it obviously changes. Okay, because there is a change in the medium, so there was obstacle in the path of light, therefore its speed changed. When the speed changes, the wavelength of the light also changes. So basically it is the other way around. When the wavelength of light changes, the speed of light also changes, keeping the frequency constant. Okay, now the last thing that we have over here is a special case. As you can see, this is medium 1, this is medium 2. Light is trying to enter into medium 2 from medium 1, and why is this called a special case is because you can see the angle at which it is falling on the surface of separation is actually 90 degree to the surface of separation. Okay, so it is like falling perpendicularly. Okay, so does this case also involve refraction? Will the refraction be visible? Will the speed of light change in this case also? So the answer to that question is the ray of light will keep on going in the same direction in which it was going. So basically there is no refraction that is visible in this particular case, which is a special case of perpendicular incidence. You see, this is the perpendicular incidence that is that we have in this particular case. So there is apparently no refraction that is taking place. But does that mean that the speed of light in medium 1 and the speed of light in medium 2 have become same? No, there is a change in the speed of light here and here. The only thing is that it is not appearing in a bended fashion or in a bent fashion when it comes out in the second medium. Why so? Because this is a special case in which the ray is falling perpendicularly to the surface. So whenever such a case arises, although the speed of light and the wavelength of light changes in the second medium, but to the eyes there is no visible refraction that is taking place. So now in this particular case, if somebody asks you what will be your angle I and what will be your angle R, what will your answer be? Angle I, please remember, is the angle between incident ray and the normal. So here the incident ray is this. If you draw the normal will also be drawn on top of that exactly. So angle I becomes 0. Okay, 0 degrees. Similarly, angle R, which gets formed in the second medium, it's the angle between the normal and the refracted ray. This is the refracted ray and that itself is the normal. So angle R will also become 0. Okay, so please remember this special case also. Okay, now we'll continue in the second lecture. Okay, thank you students.